Hello all. In this video, we are going to construct a DFA to accept the language over sigma is equal to 0, 1 and the language L can accept the set of strings W such that W has even number of zeros and an even number of ones. So this is an example for even number of zeros and even number of ones. So this string has 2 zeros and 2 ones, and this string has 2 zeros and 4 ones. It means even zeros and even number of ones. Similarly, even number of zeros and even number of ones. So these strings must be accepted by our DFA. And suppose 0, 1, 1, 1, 0, 0, 1, 1, 0. So these type of strings must be rejected by our DFA. So this string has even 1, odd 0, and this string has odd zeros and odd ones, 3 zeros and 3 ones. So these strings must be rejected by our DFA, and even number of zeros and even number of ones must be accepted by our DFA. So we need 4 states for this problem, because we have to accept even number of zeros and even number of ones. So for that we need one state Q0, then odd number of zeros, even number of ones, then odd number of ones, even number of zeros, then odd ones, odd zeros. So we need 4 states for the 4 possible combinations. So here Q0 represents even zeros and even ones, Q1 means even zeros and odd ones, Q2 for odd zeros and even ones, Q3 for odd number of zeros and odd number of ones. And here we are going to consider Q0 as both the start state and final state, because before reading any input, we can say that we have read 0 number of zeros and 0 number of ones. So 0 zeros and 0 ones means no zeros and no ones. 0 zeros means 0 is also an even number. So that the meaning is we have read even zeros and even ones at the start state. So even number of zeros and even number of ones means Q0. So Q0 is considered as start state, and this is also considered as final state, because in our problem we are going to recognize all the strings having even number of zeros and even number of ones. So Q0 is considered as both the start state and final state, and these even zeros and odd ones, number of zeros and ones are represented here also. I have written even zeros, even ones here. Q1 means even zeros, odd ones, Q2 odd zeros, even ones, and in Q3 odd zeros, odd ones. So now we have to construct the transitions from each and every state. So in Q0, if 0 is the next input symbol, we have already recognized even zeros and even ones. The meaning is 0 number of zeros and 0 number of ones are already recognized. The next input is also 0. So even zeros will become odd zeros, right? If we add one more 0 to the even number of zeros, then it will become odd number of zeros. So if 0 is the next input, then it will become odd zeros and even ones. So odd zeros and even ones means Q2. So from Q0 to Q2, draw an edge, and that edge should be labeled by 0. Similarly, in even number of zeros and even number of ones, if we add one more 1, then even ones will become odd ones. So if 1 is the input symbol, then this becomes even zeros and odd ones. Even zeros and odd ones means Q1. So Q0 to Q1, there is a transition on input symbol 1. Now we have to consider Q1. So in Q1, the meaning is we have already recognized even number of zeros and odd number of ones, right? Because if you consider this path, we have 1, 1. 1, 1 means odd number of 1, and 0 number of zeros means even number of zeros. Now we are going to add one more 0 here. So if we add 0 here, then it will become odd zeros and odd ones. So from odd zeros and odd ones means Q3. So Q1 to Q3, there is a transition on 0, input 0. Now consider the same path, 1. We have recognized 1, 1. means odd number of 1's. Or we can consider simply this condition alone. So even 0 and odd 1, if we add one more 1 here, then it will become even 0's and even 1's. Even 0 and even 1 means Q0. So from Q1 to Q0, there is a transition on input 1. Now consider Q2. Q2 case is odd 0 and even 1. Now consider 0 is the input symbol. So it becomes even 0's and even 1's. So even 0 and even 1 means Q0. So from Q2 to Q0, there is a transition on 0. Then if we add 1 here, then it will become odd 0's and odd 1's. So it should go to Q3 for the input 1. Then from Q3, if we add 0, then it will become even 0 and odd 1. Even 0 and odd 1 means Q1. If we add 1 here, then it becomes odd 0's and even 1's. Odd 0's and even 1's is Q2. So for the input symbol 1, Q3 change its states to Q2. So this is the transition diagram for the DFA. We can also write the 5 TPL notation for this. So DFA D is equal to set of states Q0, Q1, Q2, Q3. Input alphabet 0, 1. Delta is a transition function that is represented as a diagram here. Then Q0 is a start state. Final state is also Q0. So this is the 5 TPL notation. Now we can consider an input string 101101 and check whether this input string is accepted by our DFA or not. Since this input string is having even number of 0's and even number of 1's. It has 2 0's and 4 1's. So it should be accepted by our DFA. So we can check from the start state. We have to start. So 101101. 1 0 1 1 0 1. It reaches the final state Q0. So it is accepted by our DFA. Now we can consider another string. It has even 0's but odd 1's. So it should be rejected by our DFA. So 0 1 0 1 1. So since Q1 is not a final state, we can say that it is rejected by our DFA and it has even number of 0's and odd number of 1's. So it ends with the state Q1. Similarly, if we consider odd number of 0's and odd number of 1's, we will end up with state Q3. So this is a DFA transition diagram for accepting all the strings, all the binary strings having even number of 0's and even number of 1's. Thank you.